Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. And make sure to stay until the end of the video where I have a bonus problem that's similar to this one which you guys can try to solve. Alright, so we have x to the power of x is equal to 10 to the power of 200. Now for our solution, so we start with x to the power of x is equal to 10 to the power of 200. Now 200, this is equal to 2 times 100. So I'm going to replace 2 times 100 with 200, so now I have x to the power of x is equal to 10 to the power of 2 times 100. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. And the same thing goes vice versa. If I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So in this case, a is equal to 10, m is equal to 2, and n is equal to 100. So this would equal x to the power of x is equal to 10 to the power of 2 to the power of 100. Now, we can simplify with some in parentheses. 10 to the power of 2 is simply 10 times 10, which is 100. So now I have x to the power of x is equal to 100 to the power of 100. Now, if I have something in the form a to the power of a is equal to b to the power of b, then this means that a is equal to b as long as b is greater than or equal to 1. In this case, b is equal to 100, which is greater than or equal to 1. Meaning x is equal to 100. Now, to check, I have x to the power of x is equal to 10 to the power of 200. Now x is equal to 100. So now I have 100 to the power of 100 is equal to 10 to the power of 200. Now 100 is the same as 10 squared. So now I have 10 squared to the power of 100 is equal to 10 to the power of 200. Now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 10 to the power of 2 to the power of 100, that equals 10 to the power of 2 times 100, so equal to 10 to the power of 200. 2 times 100 is 200, so I have 10 to the power of 200 is equal to 10 to the power of 200. Because this is right, our solution is right as well. So we have x to the power of x is equal to 5 to the power of x plus 25. Now, the first thing is, if we have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, we have 5 to the power of x plus 25. We can think of a as 5 here, m as x, and n as 25. So now we have 5 to the power of x times 5 to the power of 25 equal to 5 to the power of x. So now we have x to the power of x is equal to 5 to the power of x times 5 to the power of 25. Now if I divide both sides by 5 to the power of x, these two cancel out, and I'll have x to the power of x over 5 to the power of x is equal to 5 to the power of 25. Now, if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So in this case, x to the power of x over 5 to the power of x, that's going to equal x over 5 to the power of x, which is equal to 5 to the power of 25. Now, if I take the power of 1 over 5 on both sides, I get x over 5 to the power of x to the power of 1 over 5 is equal to 5 to the power of 25 to the power of 1 over 5. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So for x over 5 to the power of x to the power of 1 over 5, that is going to equal x over 5 to the power of x times 1 over 5. Now this is equal to 5 to the power of 25 to the power of 1 over 5. That's going to equal 5 to the power of 25 times 1 over 5. Now x times 1 over 5 is simply x over 5, so I have x over 5 to the power of x over 5 is equal to 5. 25 times 1 over 5 is simply 5. Now, if I have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b, as long as b is greater than or equal to 1. And in this case, b is 5, which is greater than or equal to 1, meaning a is equal to b. So in this case, a is x over 5 and b is 5. So I have x over 5 is equal to 5. Now, to simplify this, I'm going to multiply both sides by 5. So now these two cancel out, and I'll be left with x is equal to 5 times 5 is 25. Now, to check, our original equation was x to the power of x is equal to 5 to the power of x plus 25. Now we know that x is equal to 25. So now if I plug in 25 for x, I get 25 to the power of 25 is equal to 5 to the power of 25 plus 25. Now 25 plus 25 is 50, so now 25 to the power of 25 is equal to 5 to the power of 50. Now 25 here, this is the same thing as 5 squared. So now I'm going to replace 25 with 5 squared, so now 5 squared to the power of 25 is equal to 5 to the power of 50. Now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 5 to the power of 2 to the power of 25, that would equal 5 to the power of 2 times 25. So equal to 5 to the power of 50. 2 times 25 is 50, so I have 5 to the power of 50 is equal to 5 to the power of 50. And because this is right, our solution is right. Alright, so I have x to the power of x is equal to x to the power of 2. Now what I'm first going to do is I'm going to divide both sides by x to the power of 2. So then these two will cancel out, and now I will be left with x to the power of x over x to the power of 2 is equal to 1. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So in this case, a is equal to x, m is equal to x, and n is equal to 2. So I'm going to put this in the form a to the power of m minus n, which in this case a is x, so I have x to the power of m minus n. So x minus 2, and this is equal to 1. Now I'm going to take the ln, or natural log, on both sides. So now I have ln of x to the power of x minus 2 is equal to ln of 1. Now, if I take the ln of something, say ln of a to the power of b, I can actually move this exponent b to the front of the logarithm. So this would equal b times ln a. And the same goes for log. If I take the log of a to the power of b, I can actually move this exponent to the front, so this would equal b times log a. And the reason this is useful is, let's say that we have 5 to the power of x is equal to 7, right? And in this case, we're solving for x, and as you can see, x is an exponent here. But if we want to solve for x, we want it to be a real number, or a real term. So now, if we take the log on both sides, now we can move this exponent x to the front, so now I have x times log 5 is equal to log 7, and now I can divide both sides by log 5. These two cancel out, and I'll get x is equal to log 7 over log 5. So that is what is really useful about this property. Alright, so now going back to our problem, we had ln x to the power of x minus 2 is equal to ln 1. Now I can move this exponent x minus 2 to the front, so now I have x minus 2 times ln x is equal to ln 1. Now, ln 1 is the same thing as 0. So now I have x minus 2 times ln x is equal to 0. And now this gives me two equations. I have x minus 2 is equal to 0, and I also have ln x is equal to 0. For x minus 2 equals 0, I can simply add 2 on both sides. So these two cancel out, and I'll be left with x equals 2. So this is one solution. Now for ln x equals 0, x is equal to 1. Alright, so now to check, we had x to the power of x is equal to x to the power of 2. Now if we first plug in x equals 2, I get 2 to the power of 2 is equal to 2 to the power of 2, and this is right. Now if I plug in x equals 1, I get 1 to the power of 1 is equal to 1 to the power of 2, 1 to the power of 1 is 1, and 1 to the power of 2 is also 1, so this is right as well.
Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this algebraic problem. So we have the square root of negative 5 times the square root of negative 5. And many people actually get this simple problem wrong. So what many people do is they see square root of negative 5 times the square root of negative 5, and then they simply just multiply negative 5 with negative 5 in the radical. So they go the square root of negative 5 times the square root of negative 5, and negative 5 times negative 5 is 25. So this would be the square root of 25, which is equal to 5. So many people think that 5 is the right answer. However, this is wrong. So the right method is to first rewrite the square root of negative 5 as the square root of negative 1 times the square root of 5. And I'm going to do the same thing with this. So this times the square root of negative 1 times the square root of 5. Now, if you guys know what I is, it's the imaginary number, and it is equal to the square root of negative 1. So now I'm going to replace all these square root of negative 1s with I. So now I have I times the square root of 5 times I times the square root of 5. So now we can multiply both i's, so I get I squared times the square root of 5 times 5. Now I squared, well, I is equal to the square root of negative 1, so I squared would equal negative 1. And I'm multiplying this with the square root of 5 times 5 is simply just 5. So now I have negative 1 times 5, which is equal to negative 5. So negative 5 is our answer.